Alright, good day students. Today we want to look at a very important question. Uh, the question looks like a challenging question, which is not actually challenging in a research or actual sense. But the question is to find the differential coefficient of the function with respect to x. So, to differentiate the function with respect to x, or for this function we should find the y, differentiation of y with respect to x. Now remember, for implicit function you can either use implicit differentiation or we use the method of partial derivative or differentiation. Now for any implicit function, we know that the dy over ds must be equal to the minus or the negative of the partial derivative of x divided by the partial derivative of y. Now what is the meaning of partial derivative of x? It means we should differentiate the function with respect to x only and take any other term to be a constant number. Then what the partial derivative of y means, we should differentiate the function with respect to y only and take any other term to be a constant. Now the first thing before applying this formula or model or shortcuts, or what you can call it anything you wish, the first thing is to ensure you equate the function to 0 in order not to have issues with your signs. So you are going to move everything in the right hand side to the left hand side and equate the whole function to 0. So if you move this xy across this equal to sign, then you are going to have minus xy because it was plus here. Cross this equal to sign is going to become minus xy. So I'm going to have exponential s plus y, then minus sy, everything equal to 0. The first thing, we are going to find our derivative of x, partial differentiation of x of this whole function. It means differentiate only the x and take y as a constant number. So to differentiate exponential x now, the first thing, remember for exponential function, we differentiate the power, then use the answer we are going to get to multiply the question. That will be the answer to the problem. If you know you don't know that, go and look at my exponential function video. I've done the differentiation of exponential function. One look at it, it's a very simple thing. Differentiate this power here, differentiate x, you're going to have 1. Differentiate y, that will be 0 because there's no s here. So that is 1 plus 0, that is 1. 1 times this same function will be the same function. You can look at it here. 1 times that same function. Minus, differentiate only this s out and leave y alone because y is not a constant. Since we are looking at partial differentiation. So differentiate s out, so you're going to have 1, then you leave y. So 1 times this remain the same, 1 times y remain the same. Now for partial derivative of y, we are going to differentiate the same function, but this case we are going to differentiate it with respect to y and take any other term there as a constant. Now let's differentiate the power first. Remember this exponential function, differentiate the power, use the answer to multiply the question. Now differentiate x, there's no y in this place. This first term in this power, there's no y here, that will be 0. Differentiate this y, we have 1. 1 plus 0, that is 1. Do there. They use that one to multiply this same question. That will give you the answer to that exponential function. Then minus, differentiate this, okay, since we have sy, differentiate only the y, leave the s alone. Since we have sy here, s cannot be 0 here, since y is here, standing close to the x. As mean s was alone to become 0. So since y is here, differentiate only the y, then leave the s. We have 1. 1 times x, we have x. 1 times exponential s, we have this. The next thing, apply this formula minus ds. Ds is this, we have minus this, which is this, then over dy, which is this. That will be the final answer. Thank you, and God bless you. In case you have any issue with this, ensure you watch our videos that have the tag exponential functions and implicit differentiation. Thank you. God bless you all.